Okay, am I audible? Okay, so Apple really wants you to add machine learning to your apps. And in this talk, I'll show you some of the tools you can use. And this is a practice run of next month's Try Swift talk. So I joined the Ray Wenderlich team 4 years ago after retiring from 25 years as a computer science academic. You might have seen my watchOS book chapters or my video courses on concurrency and networking or some of my tutorials. When Apple announced CoreML at WWDC 2017, we published a tutorial about it on the morning of the last day of WWDC. It wasn't deep, but we were the first. Earlier this year, I wrote a tutorial on Keras and another on Watson services. Both of these are alien territory, so probably was a little scary for most of our readers. I didn't get a lot of comments on those. And then, at this year's WWDC, Apple announced CreateML. So now you can do machine learning in Xcode and Swift, not Python or strange environments or something like that. So I wrote a tutorial about that, and we were a little late. It came out the Tuesday after WWDC. But it's not just about CreateML, and I'll tell you more about that later in this talk. First, let me give you some reasons to listen to this talk. Unlike Ray's other authors, I've never worked as an iOS developer. They write about stuff they do every day. I have to learn about it before I write it. But that's my value to raywenderlich.com. I can learn stuff pretty fast and then translate it into something that other people can learn from faster than I did. I also never worked in machine learning, but I learned something about it when I did my PhD in math a long time ago, former life. The math PhD mainly helps me to see when the math isn't really needed to explain machine learning. Okay. Other authors who do work with machine learning think my tutorials are really good. So that gives me confidence that I'm not dumbing things down or getting things wrong. And here's another endorsement. Last year, Apple started publishing a machine learning journal. It's pretty high-level stuff, very technical. Their November article explained how they built the vision framework model to do face detection. It's a very technical article. I haven't read it. It's aimed at data scientists, machine learning researchers. It's that kind of language. But at the end of the article are suggestions for how to get started with the vision framework. As usual, watch the video, read the documentation, and try this tutorial, which is my tutorial. So I was pretty chuffed about that. Anyway, let's start with the broad definition. Machine learning is what that says, a field of study that gives computers the ability to learn without being explicitly programmed. Basically because we as programmers can't actually write down the algorithm. So we can't program the computers to do it explicitly, so we have to write a program that gets the computers to learn how to do it. And here's a joke. It's AI when you're raising money, and it's ML when you're hiring people. Okay, so a bit more detail. You've probably seen this before. The two broad areas of machine learning are supervised learning, where you have to label the data, and unsupervised learning, where you don't have to label the data. And for supervised learning, there's two things. There's classification and regression. And the difference between them is basically with classification, you're doing distinct classes. So, you know, dogs, cats, oranges, that kind of thing. And with regression, it's more of a continuous output, so like stock prices or something like that. And unsupervised learning basically just does clustering. So if you've seen my CreateML tutorial, there's an image similarity exercise in it. And although we feed it the same labeled data, cats and dogs, the model doesn't actually use those labels. It just looks at all the images and tries to cluster them in some way. And so then when you ask for a similar image to a particular cat, it will try and find cats the same color or cats in the same position or something like that, not just any old cat. Might find dogs as well. Okay. But there's also the difference between training and inference. So training the model means supplying it with training data and letting it calculate the formula to combine the input parameters to produce the output predictions. Training happens on computers, ideally computers with GPUs. Okay? To use the model, you give it some new inputs and it calculates the predictions. This is called inferencing. Inferencing still requires a lot of computing to calculate the outputs because it basically runs through the same model calculations as when you train. But doing these calculations on handheld devices is now possible because of frameworks like Metal. Keeping the inference on device, this is something that Apple made a big deal about last year. It's faster. You obviously get a much quicker response because it's not being sent back to a back-end server and coming back through the network. And it's good for user privacy because their photographs and their speech and whatnot doesn't necessarily have to go back to a server. Okay? So they can take whatever kind of pictures they want and analyze them. All right. Deep learning is about neural networks. So there's all kinds of different artificial intelligence algorithms out there, but the excitement right now is about deep learning and neural networks because they've had some really amazing successes since 2012 when Google used YouTube videos to train their models to recognize cats and different people. A neural network tries to model human brain processes with layers of nodes, and they need a large amount of training data. Ideally, you want a full range of possibilities in your images or your training data. And this used to be really hard to get, but now with the internet and social media, there's an explosion in user-supplied data. It's all out there. You just have to grab it. That was the data. Okay. So that's one factor in the rise of machine learning. Training a network requires a lot of computing power, and those are basically matrix operations. And CPUs, not that great at matrix operations, but GPUs are. And because of the gaming industry and the drive for faster and cheaper GPUs, it means that GPUs are now cheaper and more available for machine learning. And so that's why we have more. So now you can create neural networks with lots of layers. So this is called deep multi-layer neural networks, and so that's why we have deep learning. Okay. So is it hard, or is it a lot of work to put machine learning into your app? It depends which level of abstraction you need to work at. Apple and the other major players are trying to provide tools at the task level. So do you want to classify images or text? Do you want a recommender system? That sort of thing. CoreML was announced with a few existing models, so you don't have to do anything except include them in your app. Apple also has several frameworks like Vision and Speech and SiriKit, which you can also just use, put them in your apps. But there's CreateML and TURI Create. They let you customize existing models with your data. Okay, so you're not stuck using a model that was trained on whatever ImageNet or something like that. You have your own images or your own text that you want to classify. You can train one of these heavy-duty models with your data. And that's, Google's calling it AutoML, and its official name is transfer learning. And if you go to Apple's webpage about machine learning, it says, you don't have to be a machine learning expert. Okay, they're trying to reassure you that you don't have to go out and learn all the maths Just use their tools. Okay? So the frameworks and the task-focused toolkits cover most of the things that people want to put into iOS apps. But you might have something that doesn't fit into that. What happened? Whoops. It went dark. Okay. All right. So yes, might not find anything that fits. So you might have to build your own model. So that's the next level of abstraction. It's a bit lower. And when you have to build your own models, then you have to start learning about neural network architectures and talk about hyperparameters and activation functions. And if you go back and look at my Keras tutorial, that talks about some of the layers and tries to explain a lot of these things and why you might make certain choices in the model architecture to get a smaller model, for example. If you've looked at online courses on ML, or some of the books that are out there, and you've probably seen a lot about writing or coming up with efficient algorithms. And they talk about things like gradient descent, and there's, oh, it's gone again.
I didn't do that one.
Right. Yeah, so gradient descent, and there's a lot of complex math. The Apple ML Journal article is sort of like that. It talks a lot of jargon at that level. But as an iOS app developer, you don't need to learn any of that. Your job is to learn what the high-level tools are and how to use them effectively in your apps. When the researchers develop a better algorithm, it will find its way into the pre-trained models or into Keras. And you don't have to do anything, it'll just be there, and you'll start using it. Okay? So throw away all those books. All right. So here are all the Apple things. And I'll talk more about them in the rest of the talk. So first of all, there was CoreML, and that came with a bunch of existing models. They call them ready to use. All of them were for detecting objects in images or for classifying places in images. So it was all image-oriented stuff. And they also supplied CoreML tools. That was for converting models that were created with things like Keras or other Python or horrible things, non-Swift things. And then later in 2017, they released TURI Create. This was a sort of a framework that they bought from a startup group in Seattle, which came out of a university. And it was their first AutoML tool. So it was the first tool that lets you add your data to an existing model and create a classifier for your data. Okay, but it was in Python. Python's very scary. Although Python lives in your Mac, it comes with the Mac OS. You have Python already built into Mac OS, but if you start trying to use that for this, you start running into all these packages that you have to download, and then you start running into all these version issues all over the place, and then you discover that, oh, you need virtual env. You have to have not just a package manager, you have to have an environment manager, and it starts just to get too hard. Just forget about it. Okay. So yeah, Python's scary, but just wait. All right. And then, so they noticed that people weren't really using these tools, and so they came up with CreateML. Okay. And CreateML lets you do machine learning in the comfort of Xcode and Swift. But it only lets you do a couple of things. The two most popular things that people want to do is in CreateML. So I see CreateML as a kind of a stepping stone to lure you towards TURI Create, unless you want to wait and wait and wait. Okay? Now there are other things as well. There are the frameworks. So obviously Vision Framework came out last year. There's also natural language to process text. And there's the speech framework, which lets you convert speech to text and optionally retrieve answers, kind of like Siri. It requires a network connection, and there are limitations on the data length and the quantity of requests that you can make to the server. But if you've got an A9 device, you can actually write into your app to check whether or not there's on-device speech recognition. And in that case, you can just, offline, you can use dictation. It won't go off and find answers, but you can certainly do dictation. My little SE does that. And then there's SiriKit, which there's still only a few limited use cases for SiriKit that you can use. And there's a bit of AI in Gameplay Kit. It can evaluate decision trees. Okay, so there are these frameworks. Tonight, I'll just talk about the vision framework. Yeah. So that was announced last year, and it detects faces, including small faces and profiles and hidden faces, partially hidden faces, faces under hats or behind glasses. And it can find face landmarks in case you want to put funny hats or glasses or beards on photographs of your friends. And it can detect rectangles and barcodes and text, and all that kind of thing. Just quickly how to use it. There are two types of request handlers for image and sequence. Each involves a request handler, a request, and a request completion handler. You need one request handler per input image, but you only have one request per completion handler, independent of the image, and you can perform an array of requests. So that's all I'll say about frameworks. You can download 6 ready-to-use models from Apple's CoreML pages. TURI creates image classifier, uses SqueezeNet, the first one, and down towards the bottom is ResNet. So you can use either one of those to build your own image classifier. It's the object recognition and image similarity toolkits use something like the very last one, the VGG16. But all of these models were designed for back-end inferencing. They're designed for apps that take the data from the user, send it back to the back-end server, gets processed there, and the answer gets sent back. So they tend to be sort of big. When you're adding a model to your iOS app, size matters. You don't want something huge going into your iOS app. So what are the sizes? The first 3 aren't too bad. Sort of 5 megabytes, 17, 25 megabytes. The next 2 are closer to 100 megabytes going into your app. The last one is over 500 megabytes. Okay? So I'll talk more about size when we get to CreateML and TURI Create. Just remember the range of sizes here, so between 5 and 500 megabytes. Okay, just keep in mind. Okay, if you can find a model that was created by one of the green tools, you can convert them with the CoreML tools that came out with CoreML. But it's still Python. Okay, so I don't think people have used them a lot. The purple tools have their own CoreML converters. They don't use the standard one. But again, they're all alien territory. Watson gives you a Swift project, but it wraps their CoreML model in their own vision model. It's all sort of several layers deep inside there. Plus, you have to navigate through IBM's website, which is pretty horrendous. TensorFlow says that they have a CoreML converter, but the fine print is it cannot convert certain parts of TensorFlow. So certain of the different tools in TensorFlow that you would put into your model, if you put them in, you can't get a CoreML model out of it. And you kind of don't know, it's a gotcha, you sort of don't know until you try to do it. And why would you try? TensorFlow is pretty hard to use. So I don't think you would actually do it. Okay, so AutoML. The idea behind AutoML is you just add data. But that just is a big just, because collecting and cleaning data is actually the most time-consuming and expensive part of machine learning. All the rest of it is relatively easy. You have to get the data right. Okay? These are some of the 4,800 images for a healthy snacks classifier. There are 20 classes with about 350 images each. My co-author hand curated I don't know how many thousands of images to get these 4,800. Okay? Some of the images have people in them because the expectation is that when the app is going to be used, you're going to be, taking pictures of food, and there are going to be people around. So it has to be able to cope with the fact that there are people in the image. But you look at this one. The dominant part of this image is a blue T-shirt, which has nothing to do with the food. So you have to provide enough images so your model doesn't think that big blue blobs means ice cream. Right? The other thing is image classifiers all require their input images adjusted to a few hundred pixels square. A couple hundred by a couple hundred pixels, which means you lose a lot of detail. Okay? So you don't want the object of interest in the image to be too small, because by the time you get down to 300 by 300 pixels, it's not there. It's like a couple of pixels or something. Okay? Ideally, you want a lot of images, but that's not always possible. And so data augmentation generates additional images from your data set by flipping, skewing, rotating. Again, when you're using an app, especially with a phone, very often your image isn't going to be straight on, and the exposure might be, not so great and stuff like that. So these are reasonable permutations to do to your images. Right, transfer learning processes each image through all the layers of the base model except the last. The last layer is what actually generates the classifier. Okay, so for these big models, it's generating a classifier for like 1,000 or several thousand classes. You might only want 20 in our case. Okay, so all the previous layers extract the features that the model has decided are useful for classifying. Okay, so this is actually running through most of the model's calculations, right? So the features are edges, shapes, relationships between shapes, that sort of thing. So AutoML tools will then analyze your data to try and select the most suitable base model. Okay? That's what all AutoML tools do, so you don't have to actually think about like which model do you want to use. They will analyze your data and try and pick the best one. CreateML's image classifier only uses the one that underlies the Vision framework. It has this really catchy name, Vision Feature Print Screen. And it's large. It has 2,048 features. And so the feature extraction takes a bit of time. Instead of that final classification layer that comes with the base model, transfer learning will then train what's called a logistic regression classifier to get the classes that you want. So if you don't want 1,000 different classes, you just want 20, it's going to train for 20 classes. Okay. Logistic regression is kind of like linear regression. You've probably done this or you've seen this done, where you have a bunch of points in XY space and you're trying to fit a line through them and you do least squares and that kind of thing. So logistic regression is a similar kind of thing, but it's a lot more transformations required because it's working in 2,048 dimension space, and it tries to do transformations on the points so that it can draw decision boundaries between the different classes as much as possible. That's as much as I'll say about that. Okay. CreateML's image classifier is a spectacular party trick. It's drag and drop training. You create a macOS playground. In 2 lines of code, you create and show an interactive window in live view. Xcode 10 playgrounds, by the way, behave more like Jupyter notebooks than what you're used to. So you can select an individual line of code, press Shift-Enter, it will only run that line of code. Okay, so you can sort of go back and forth within your code and just pick and choose and say, I want to just do this bit again. The images supplied to CreateML are in separate folders, each one named for the class that they represent. So apple, banana, cake, cookie, that kind of thing. Okay? Training starts as soon as you drop the data in. It starts extracting features from the 4,800 images. I did this first on my 2016 MacBook, and it took 35 minutes. I got a brand new 6-core i7 with Radeon 560 GPU, and it did it in less than 3 minutes. Okay? So, yeah, well, training the classifier then will take just a few seconds. Okay, so it took under 3 minutes to extract all the features. It takes a few seconds to actually train the classifier. What the classifier does is it first sets aside 5% of the images for validation. So it's calculating predictions for these validation images. Any errors don't get fed back into the calculation of into the training of the model. They're just there. They're just there for validation. So at the end, you see that, I don't know if you can see, there's a 91% training accuracy and there's an 88% validation, 89% validation accuracy. So at the end, you want those two numbers to be close. If what's going on? Okay. Right. If the training accuracy is way more than validation accuracy, it means the model is learning too much about specific images in your training data. It's called overfitting. Okay? And it doesn't do you any good because when you go to use the model, it's not going to be looking at your training data. It's going to be looking at new data. So you don't want those two numbers to get too far away from each other. The selection of the validation images is random. So every time you run the trainer, you can get different accuracy values. Okay? What it's doing here is after it's finished training, it's prompting you to drag and drop test images so you can evaluate. Is this like the lights that go off sometimes? You have to sort of wave. Yeah, okay. So after the training, the window will prompt you to drag in some test data so you can evaluate it. Right. If you don't like the training results, so say your training accuracy is like, way too big relative to your validation accuracy and you think, no, I better do something else, then you can restart the window. And then you click the little disclosure button on the window and you see some options here. These screens are really too small, actually. Yeah, so you can, for example, increase the maximum iterations on the classifier trainer. So the default is 10 iterations. It will look at all of the images 10 times. Look at all of the images 10 times, and you can increase that to 25 or 30 or something like that. If your model is overfitting, increasing the max iterations isn't going to help. It'll just make it worse. On the other hand, if your two numbers are very close, but they're not very high, increasing the max iterations is likely to get you better accuracy. But as soon as they start growing apart, you don't want to just keep increasing iterations at that point. What you might want to do is use your own validation data. So you can have a separate set of validation images, and that way it's always the same validation data, so you at least kind of know that you're always testing against the same things. You can also have more validation images than just 5%. And then the other thing you can do is data augmentation. So you can flip, rotate, change the exposure, or do some shearing. Okay? So I checked the flip thing, and that actually generates 4 more images for each original image. Okay, so 5 times as long to do the training. I actually originally clicked all 4 boxes, and I went to look at it after a while, and I said, why is it taking so long? It generates 193 images for each original. So it would have taken 8 or 9 hours on my brand new MacBook Pro. So it's a playground, you just stop it. You just uncheck the boxes. Okay. After drag and drop testing, you can rename the model, you can save it as CoreML, and then you drag it into the project navigator, and it generates a class. And, oh, do you remember the sizes of those ready-to-use models? So they were between 5 and 550 megabytes. This model is 312 kilobytes. And it's better than most of the other ones that are there because it's based on the vision framework model.
So it's more targeted.
Well, it's the one that finds all the faces and everything. So this CoreML2 that they talked about at WWDC, they're taking these base models and they're putting them in iOS 12. So that whole vision framework model is already in iOS 12. It doesn't have to go into your app. Bonus. Okay. So now you have your Healthy Snacks class. You just create one. You wrap it in a vision model, in this case, because it's about images. And that will take care of converting your input images to the right format. Here's a bit from the text classifier. So the CreateML text classifier doesn't have a GUI, so you have to write code to do it all. You can write the code for the image classifier too, but it's more fun using the drag and drop. So the example in the documentation for the text classifier shows input coming from JSON or CSV files, just like TURI create. Okay, so it's a very standard way to get input into a text classifier. But if you watch the CreateML video, he gets his input, is the sentiment classifier, he gets his input from a set of folders that are labeled, just like images. And the way you do it is this enumeration here, .label directories at. So you have the URL for where the directories are, and then you use this label directories at thing, and it unwraps everything and loads up your data just the way it should be. So that's something that you get in CreateML and not in TURI Create. Also, if you want to see another example, this is Matt Thompson's tutorial on using the CreateML text classifier. Oh dear, okay. Sorry. The TURI Create, you get 5 more task-focused toolkits. In addition to image and text, you get those other 5 things, including some very cool things like style transfer and image similarity. But it's still in Python. You could wait and see if Apple adds them to CreateML, but if you want to try them out sooner, the other half of my CreateML tutorial tries to make it easier for you to try TURI Create. It shows you how to install Anaconda, then you can use its Navigator GUI to import the turienv.yaml file. So I've created the whole environment for you to do TURI in, and you just import it through the Anaconda Navigator, and then you've got the environment. It's already set up with TURI Create version 4, which does not need Mojave. And then you can just launch the Jupyter Notebook directly from the GUI. It opens in your browser, and then the tutorial will walk you through customizing an image similarity model for cats and dogs. Okay, so just trying to make it as easy as possible. And I think it's working. Some people have been using TURI Create. Okay. TURI Create is a little more manual, but not much more than the text classifier in CreateML. So for the image classifier, you have to do some path wrangling. It's really too small. Path wrangling to get the class labels from the subfolder names. And then you can train with the same base model as CreateML, but you would have to be on Mojave and you would have to pip install TURI Create v5b3. Okay, it's not that hard. You go to the TURI Create website, GitHub, and it has a link there for the TURI Create version 5 beta. But something is happening under the covers, because this is using the same base model as CreateML, same data as CreateML, but the accuracies when I ran it are a little bit lower, and the model is half the size. So I haven't figured out what's going on there, but it's not exactly the same. Okay, TURI Create is a little more manual. Oh, did I? Sorry, I did that already, did I? Hold on. Here we go. Okay, so TURI Create's more manual, but it gives you more control over visualizing the results, like this nifty little heat map of the confusion matrix for the test data. So the horizontal axis is the predicted label, the vertical axis is the true label. Numbers on the diagonal should be warm colors. Okay. Any large numbers off the diagonal means that there are images that the model got wrong. In this case, it's mainly cookies and muffins that are being confused. Okay? And so you would want to look at getting more images to distinguish cookies from muffins and the other way around. Right, so try it. Start with ML in Xcode and Swift with frameworks and CreateML and CoreML. And then try TURI Create in Anaconda and MyTuriEnv. And then maybe venture into AutoKeras or Keras. Now, although you can install Keras through the Anaconda navigator, it needs TensorFlow. And the TensorFlow installation instructions say to use pip. So you should do that for Keras as well. Okay. If you want to try other data sets, this is a plug for Kaggle, which was created in 2010 by Anthony Goldblum in Sydney, and was bought by Google last year. It runs model prediction competitions, and the machine learning community contributes data sets, some with notebooks that analyze and visualize the data. So where to go from here is the usual websites, my Twitter handle. Oh, and one more thing. If you're on the Ray Wenderlich mailing list, you might have seen this call for a co-author to join Matt Tice and me. Matt Tice wrote iOS Apprentice. He's a consultant for machine learning. And there's just me. And then Ray chose a guy named Chris LaPolla, who seems to have some sort of history with the site already. He's done some work for Udacity's machine learning courses. So I'll be meeting him on camera tomorrow morning at 6 a.m. So thanks for listening. Whoops. Any questions?
So it seems like Apple has been, slowly but surely going towards following along the path of making it easier for people to use these models and to train them themselves. And now that they've got CreateML, it seems like they've kind of reached the end of that road. What do you think will be Apple's next focus?
I never try to second guess. We have Apple people here, and I don't know if they know anything, but actually, CreateML only has 2 of the 7 toolkits. So at the very least, you might hope that they're going to add the other 5 to CreateML so that people don't have to do Python at all. Yeah, aside from that, no idea.
Any more questions?
With the TURI Create tool, you said that the size was like super small for that. Are they utilizing the transfer learning as well to, I guess, take advantage of the existing?
Yeah, TURI Create is doing transfer learning. It's the first one. I mean, CreateML, the same word create is not a coincidence. So I think CreateML is basically just Swift versions of a couple of the things that are in TURI Create, except it's not quite the same because, as I said, the accuracies are a bit different and the models come out different sizes, but it's basically doing the same thing.
When you mentioned, I guess, that the, I guess CreateML only does the image and the text recognition, does TURI Create kind of do the other, I think there was the data sets, and I guess you could feed it more generalized data in the, I don't remember whether it was the CreateML or the TURI Create. Do they, yeah, that one.
Oh, yeah.
Do they do transfer learning on those other ones as well?
Yeah, they all have an underlying base model. For example, the image similarity and the object detection are based on that really big VGG thing, the 500 megabyte thing. Yeah, so they all, but for some of the other things, there are probably more than one possible base model, and that's where they look at your data and they try to pick the best one. And it's totally, you don't have to worry about it.
Thanks.
You just hope that they get it right.
Hi, regarding overfitting, you said if there is 25, we can increase to 35.
Sorry?
But overfitting the data, like clustering, while clustering the data in machine learning, sometimes overfitting data or underlying outlining data might be important sometime. So it's not always not important while overfitting or underfitting.
Well, if you're overfitting, means that you're doing more training than is good. Because I've actually did an example where I just let it go for 50 iterations, and the validation accuracy goes down. So you end up with something that's 100% accurate on your training data, and it performs worse.
Yes, it performs well,
Yeah.
but not always. Sometimes it might find out the odd possibilities as well while finding machine learning, or because it is something unique from the others in the sense of clustering the data.
Well, what it's doing is it's training too much on your training data, which is not the real data that you're eventually going to use.
Okay.
So it's kind of a waste, basically.
Any more questions? Yep.
It's just a clarification, I think. The TURI Create models that, the models that TURI Create produces, they just import directly into Core ML, do they? Like they're the same models that would come out of CreateML? Like are they interchangeable?
I mean, you have to do it in code. So you basically, within TURI Create, you've got two different commands that you can use. One will create a TURI Create model that you can reload back into TURI Create, and the other one will create a Core ML model.
Right, so TURI Create can produce Core ML models?
Oh, yeah.
Yeah, okay. It's just clarification.
Yeah.
Any more questions, guys? No? I have one then.
Oh, right.
It might be a little bit off topic, but have you looked at any of the cloud model creation services and how they compare to CreateML?
No, because this one's about Apple.
That's why it's a little bit off topic. Just curious to see if you've done any research in that area yet.
No, because if people won't even use TURI Create, they're not going to go off and use Amazon.
Well, they can actually. If you can throw Amazon's hundreds of hours of compute power at it for $1,
Yeah.
rather than wait 9 hours for your MacBook.
Yeah, well, apparently Google's wanting $20 an hour for their new service. And
Ouch, that's
yeah.
quite expensive, yeah.
I mean, there's no trial either. It's just like, shell out your money and see what you get.
Cool. Thank you. That's it. Thanks, Audrey.
Right.